Hello there, good afternoon. Today I will go over one of my old tests in preparation for your test one. Now, my test one consists of two parts. The first part is without calculator, non-calculator. Okay, basically you don't use calculator when you answer this part, and then the second part you use calculator. Now, I do not make any restriction on how many hours or how many minutes you need for your calculator part and how many minutes you need for your non-calculator part. Okay. In your case, it simply means that, oh, okay, when it is non-calculator means you don't use calculator when you do those problems. Therefore, the answers has to be in exact form. Okay. Oh, by the way, when I say non-calculator, you don't use calculator at all. Okay, not even your cell phone calculator. On the other hand, when you use calculator, for the part that you use calculator, okay, it has to be calculator, not calculator feature from your smartphone. Okay, it has to be calculator. Okay, now let's go back. So your test will be 2 hours. Okay, and my suggestion is when you do my test is the following. You see the numbers here. Okay, you see the numbers there. Now this number here tells us the number of points for this question. Okay, so question number 1 worth 6 points. Okay, but okay, so for number 1 we need to finish it in 6 minutes. That's how you study. Okay, of course in the real test feel free to get a bit extra time, but what I'm trying to emphasize is this, like for number 1 the allocated time is approximately 6 minutes, right? And even though you can answer all of this correctly, you should not be happy if you answer them correctly in 20 minutes, for example. That's way too long. That's way too long. Okay, now let's see. Okay, we have cosecant, cosine, and cotangent of these angles to work with. Okay, now then let's start with 0 degrees. Sine 0 degrees is 0, right? Cosine 0 degrees is 1. So tangent 0 degrees is 0. Now, cosecant theta, cosecant 0 degrees is the reciprocal of sine. So this is undefined. Cosine 0 degrees is 1. Cotangent 0 degrees is the reciprocal of tangent. That's 0, 0. Okay. Now, and then how about sine 30 degrees? Let's work on 30 degrees. So you don't need to do it in this order, but you basically can choose, oh, you know what, let me do work on 30 degrees first. Sine 30 degrees is 1/2. So cosecant will be the reciprocal of that. Okay, cosine 30 degrees is radical 3 over 2. So this is radical 3 over 2. Tangent of 30 degrees is 1 over radical 3. So the cotangent will be the reciprocal of that, radical 3. Okay. Now, how about 45 degrees? So sine 45 degrees is 1 over radical 2. The reciprocal, therefore, is radical 2. Cosine 45 degrees is the same to sine 45 degrees. That's 1 over radical 2. Tangent 45 degrees is 1. So cotangent, the reciprocal is the reciprocal of 1, which is itself 1. Okay. Now then for 60 degrees. 60 degrees. Sine 60 degrees is radical 3 over 2. So cosecant 60 degrees is the reciprocal of that. Now then from here we rationalize the denominator, multiply the top and the bottom by radical 3. We get 2 radical 3 over 3. Cosine 60 degrees is 1/2, right? And tangent 60 degrees is radical 3. Therefore, cotangent 60 degrees is 1 over radical 3. Rationalize the denominator, that's radical 3 over 3. Okay, how about 90 degrees? Sine 90 degrees is 1. So cosecant 90 degrees, which is the reciprocal of sine, is just reciprocal of 1, which is 1. Now, cosine 90 degrees is 0. Okay, tangent 90 degrees is 1 over 0, which is undefined. Now, cotangent will be 0 over 1, right? Which is 0. That's it. Okay, now that's for question number 1. Let's go on to question number 2. Let cosecant theta equals to x, and theta is in quadrant 4. Oh, hold on. Cosecant theta is equals to x, but cosecant is the reciprocal of sine, right? I think this is the sine theta supposed to be. Cosecant theta equals to x, so sine theta is 1 over x. Okay, sine theta is 1 over x. Let's draw an angle in quadrant 4. Let's draw an angle in quadrant 4. This is theta. Okay, it's 1 over x. Sine theta is 1 over x. So this is 1 and this is negative x. Why we call this negative x here? Well, because sine in quadrant 4 is negative, right? Okay, sine in quadrant 4 is negative, but the radius has to be positive. X is negative, right? But if I set this x here to be, if I set the coordinate here, this is something comma, sorry, not a good idea. So the y will be -1. Okay, so to have that 1 over x, the x has to be negative x. I mean, the hypotenuse has to be negative x. So that sine theta equals to 1 over x. Okay, then by Pythagorean theorem, you will see by Pythagorean theorem that this guy here is square root of x squared minus 1. Okay, maybe let's do it another way. Let's do it another way. Let's think this way. Okay, cosecant theta equals to x, but theta is in quadrant 4. So if we look at the reference angle, it should be negative x. Why? Because in quadrant 4, cosecant is negative, which means x is negative. Now, to make it positive, we need to use negative x, right? Okay, now draw that triangle. You have a right triangle with theta head here, okay, with cosecant theta head to be negative x. So this is negative x, this is 1, and this is square root of x squared minus 1. Okay, so secant theta will be negative x over square root of x squared minus 1. Let's do cosine theta first. Cosine theta will be square root of x squared minus 1 over negative x. But Thomas, I thought cosine in quadrant 4 is positive. It is true. It is true. Now, square root of x squared minus 1 is positive, right? Okay, now the question is negative x positive or negative? It's positive. X is the one negative. Okay, so negative x becomes positive. Okay, now we refer to that triangle again. Okay, how about tangent theta then? Tangent theta is opposite over adjacent. However, tangent in quadrant 4 is supposed to be negative, right? The top here is positive, the bottom also positive. We need to make it negative. So I will use negative to make it tangent theta to be negative. Now cotangent theta is just reciprocal of tangent, so this is negative square root of x squared minus 1. Okay. Now, the issue at hand is, can you find the other value or trig values with the adjustment into the plus minus? Okay. Next. Number 3, we have hypotenuse 7. The opposite of angle theta is 4. So let's find out this guy first. Let's call this A. Okay, so A squared plus 4 squared equals to 7 squared. A squared plus 16 equals to 49. A squared equals to 49 minus 16, that's 33. So A will be square root of 33. Okay, now what is sine theta? Sine theta is opposite of angle theta, which is 4 over hypotenuse 7. Oh, once we know sine theta, we also know the cosecant theta, right? That's 7 over 4. Okay, now cosine theta is the adjacent of angle theta, radical 33 over hypotenuse 7. Okay, oh, once we know the cosine, then the secant is also known. That's the reciprocal 7 over radical 33. However, I did say here, you need to rationalize the denominator. If the denominator has square root, then you rationalize that. Multiply the top and the bottom by the same radical. That way, then on the numerator, we get 7 radical 33, and the bottom we get just 33. Okay? It becomes a rational number on the denominator. How about tangent theta? Tangent theta is opposite of theta over adjacent of theta. And rationalize the denominator again. We get 4 radical 33 over 33. Now, cotangent theta is the reciprocal of tangent theta. That's radical 33 over 4, and that's it. Okay, number 4. Find 6 trig functions of theta if 3, negative 4 is on the terminal side of theta. So if we have 3, negative 4. 3, negative 4 is on the terminal side of theta. This is angle theta here. Okay, now what is the radius then? 3, 4, then the r equals to 5, right? The r equals to 5. Just use Pythagorean theorem. X equals to 3, y equals to negative 4, then by Pythagorean triple, you know that's the r is 5, right? Now then from there we go on. What is sine theta? Sine is y over r. Cosine is x over r. Tangent is y over x. Secant is reciprocal of cosine. Cosecant is reciprocal of sine. Cotangent is reciprocal of tangent. That's it. Okay, and notice that I did this question 1, 2, 3, 4 without using calculator. Okay, without using calculator. No, don't use your calculator. Don't use your calculator. if once you use your calculator, then you will get some ugly number, approximated, which is not the idea. Number 5 and 6. So 5 and 6 are the place where we do proofing. Okay? And remember, when you do proofing in my class, you need to first show the direction of the proof, like number 5. Okay, we want to prove from the complicated one. I think this is more complicated, right? So we will prove from left to right. Okay, show the direction of the proof first. Okay, and then write down LHS, which stands for left-hand side. Now then, copy down whatever you have on the left-hand side. Don't do any computation, don't do any simplification. Just write it as is. Now then, in the next step, you start your computation or start your your modification, right? For example, I have tangent here, but at the end, the answer should be in cosine. So I think what I will do is I will rewrite this into sine cosine. So tangent squared theta is sine squared theta over cosine squared theta minus 1. And then on the denominator, so I was working on this one here for these. And then next I will work on this. That will give me sine squared theta over cosine squared theta plus 1. Okay. Now you see that on the top we have fraction, at the bottom we have fractions. So we will do multiply by the LCD, multiply the top and the bottom by cosine squared theta. Okay, so notice that the yellow part here, when you multiply by cosine squared theta, the cosine squared theta will cancel. We get only sine squared theta. On the other hand, the minus 1 multiplied by cosine squared theta, there will be cosine squared theta, right? Okay, the denominator, we will have sine squared theta over cosine squared theta multiplied by this, the blue part, multiplied by cosine squared theta. The cosine squared theta will cancel. We get sine squared theta plus 1 times cosine squared theta, that's cosine squared theta. But the denominator, sine squared theta plus cosine squared theta, the denominator will be just becomes 1. Right? Just becomes 1. So this is equals to sine squared theta minus cosine squared theta. What do we need? That's simple enough though, but what we need is 1 minus 2 cosine squared theta. How do we do that? How do we do that? Well, okay, so we know that sine squared theta is 1 minus cosine squared theta. Right? So basically, I change this guy here using Pythagorean identity, becomes this. Okay, then in the next line, I will combine that like terms, 1 minus 2 cosine squared theta, which is what we have on the right-hand side. And then you close the proof. Okay. That notation, the square that you shade, is the notation to say that that's the end of the proof. Okay. Now, how about number 6? Oh, that's another hard one, huh? Okay. You see that the left-hand side is harder, like it's more complicated. So we know that's where we're gonna start. We start from the left-hand side. Copy down that left-hand side first. Now then from here, you see, we don't have common denominator. To have common denominator, I will multiply, the LCD is 1 minus sine x times 1 plus sine x. That's the LCD. minus 1 plus sine x times 1 minus sine x. Okay, now on the numerator, originally I have cosine x here, but you see on the denominator, I multiply by this, then I multiply by the same thing there. Likewise, on the second fraction, I originally have cosine x on the numerator, but then on the denominator, I multiply by this to have LCD, right? So I need to multiply the top by the same thing. It's 1 minus sine x. So we have equivalent fraction if we multiply the whole fraction, let's say this guy here, the whole fraction by the same expression on the top and the bottom. Then that way you maintain equivalent fraction. Now, the reason we have this so that we have common denominator. Okay, we have common denominator 1 minus sine x times 1 plus sine x. On the numerator, we have cosine x times 1 plus sine x. That's from the first fraction. From the second fraction, we have cosine x times 1 minus sine x. Okay, now on the top, I will distribute. Okay, I will distribute cosine x plus cosine x sine x minus cosine x plus, well, plus because we have negative times negative sign. Okay, it becomes plus cosine x sine x. Okay, you need to be patient, I know. Okay, you need to be patient, write what you need to write, stop thinking about skipping steps. Okay, if you cannot write what the next step is supposed to be, then you don't know what actually should be done. Okay, so forget about skipping steps. Okay, now on the denominator, on the other hand, 1 minus sine x, 1 plus sine x, that's difference of squares, right? So that's basically 1 squared minus sine squared x, right? Which you know 1 minus sine squared x is cosine squared x. Okay, Pythagorean identity, the first Pythagorean identity. On the other hand, on the numerator, you notice that cosine x cancels, right? Cosine x cancels. Therefore, on the numerator, now we have 2 cosine x sine x. One of the cosine cancel. And then you see here, sine x over cosine x, by definition, that's tangent. Okay, which I believe what we have on the right-hand side. Okay, 2 tangent x. So we are done with this. This is right-hand side. And okay, that's how you do proofing. That's how you do proofing. Okay, I know I usually have students asking this question, Thomas, why the proofing question you have in your test is so difficult? Well, if I make it easy, and actually this is not difficult. Okay, no, this is not difficult. It's just not obvious. It's just not trivial. When I make it easier, then you will have students skipping steps here and there without explanation. And they claim, oh, I did it in my head. Okay, try to do it in your head here. And let's see what happened. Okay, now remember, if you cannot write it down, you simply don't know what happened in between. Okay, next. Number 7, write each of the following in terms of cosine x only. Okay, now then basically in part A, for example, what relates cosine x and sine x? Pythagorean identity, right? Okay, so we know that sine squared x plus cosine squared x equals to 1, right? So sine squared x equals to 1 minus cosine squared x. So sine x will be plus minus square root of 1 minus cosine square x. Okay, actually, let me put it there. Now, how about cosecant x? Well, cosecant x is the reciprocal of sine, right? We already have the sine. So this will be plus minus 1 over square root of 1 minus cosine square x. Okay. How about tangent x? Tangent x we know as sine x over cosine x. Now we already have the cosine x on the denominator. On the numerator is the one we need to care, but we already have the sine, which is plus minus 1 minus cosine square x over cosine x. How about secant x? That's the reciprocal of cosine. What's so hard about it? Okay, so that's our number 7, and I believe that's the end of our non-calculator part. Next, number 8, use your calculator. Now again, when I say use your calculator, we do not use calculator from your smartphone. Okay, not supposed to. You are not using your smartphone as calculator. Okay, if I see that in the test, I will tell you to stop. Okay, and I will disqualify you. Okay, so don't do that. Next, so what is secant 151? Notice that we don't have secant function on our calculator. Okay, we don't have that. So what should we do first? We need to compute 1 over cosine, the reciprocal of secant 151 degrees. Then you use your calculator. What is 1 over, what is cosine 151? That's negative 0.87462, which if I use my calculator to do the reciprocal, I get negative 1.14335. 5 decimal places. Okay, now how about tangent 293? That's the reciprocal of tangent 293 degrees. Then I use my calculator. What is tangent 293 degrees? That is negative 2.35585. Then I use my calculator to do the reciprocal. I get negative 0.42447. Okay. Number 9, suppose theta is in quadrant 2. Oh, shoot, the theta is in quadrant 2. Now, what is cosecant theta? If cosecant theta is 2.795, what is theta? We need to do it this way. Okay, we don't have a cosecant function on our calculator, right? But cosecant is the reciprocal of sine. So sine theta equals to 1 over 2.795. Okay, we are going to use sine inverse. However, when we do sine inverse, you need to look at that from the acute angle only, while your theta is in quadrant 2, right? No, we cannot do that. We cannot do that. So what we can do? Well, do the reference angle first. Sine theta hat equals to 1 over 2.795. Then do the reference angle. That's sine inverse of 1 over 2.795. Okay, sine inverse of 1 over 2.795. Now you will see that you will get an acute angle, 20.96403 degrees. Now then notice that this theta head is here, right? This is the theta head. Then what is the theta? Go back to the theta. Go back to the theta. So we use theta hat only so that we can use inverse sine. Now, once you get the theta hat, you bring it back to quadrant 2, right? Now, theta in quadrant 2 is 180 degrees minus that theta hat. 20.96403 degrees. That is 159.03597 degrees. Okay. Now remember, when we do inverse sine or inverse cosine, okay, the number we get will be an acute angle. Okay, so do not attack right away with the theta. You need to deal with the theta head. So likewise here, secant theta is negative something, so cosine theta is 1 over negative 1.8293. Okay, yeah, cosine is supposed to be negative in quadrant 2, right? Okay, now the problem is we cannot use cosine inverse if the theta is in quadrant 2, right? So we borrow the idea of reference angle. Okay, cosine theta hat equals to 1 over 1.8293. Now, then from there, you see, oh, then theta hat, the reference angle will be cosine inverse of 1 over 1.8293. What's that? Cosine inverse of 1 over 1.8293. I get this is 56.86202 degrees. Now, don't forget, this is still theta hat in quadrant 2. So the actual theta, the actual angle in quadrant 2 must be 180 degrees minus the reference angle. We get theta to be 123.13798 degrees. Okay, that's for our number 9. Number 10. Radar A and B are located 350 miles from each other. They are both tracking a satellite at 40 degrees and 25 degrees angles of elevation respectively, and located above the ground between them. So let's see first. A and B. Let's say this is A and this is B. This is A and this is B. They are 350 miles from each other. They are both tracking a satellite located above the ground between them. Okay, so the satellite, let's say the satellite is here. Let's say the satellite is here. Okay, between them, right? Between them. Such that the angle of elevation are 40 degrees from A. Okay, and 25 degrees from B. Okay, so this is 40 degrees. This is 25 degrees. Okay, this is the height. Which is the question in part B. Find the height of the satellite from the ground. Find the height of the satellite from the ground. Now, there's no single step to do this, no. Okay, welcome to higher education trigonometry class that is transferable to university level. Now, this is not high school level. Okay, now the way we will do it, notice that I will break this diagram picture here into 2 right triangles. This is the first right triangle, and this is the second right triangle. Okay. Now, in the first right triangle, we have, let's call this point D here, the point right below the satellite. Okay, so AD satellite. This is angle A, right angle D, and then the satellite. Okay, we know this is 40 degrees. This is the height. We don't know what is AD. Let's call that X for now. And then the second right triangle, the one on the right hand side, let me make it a bit some distance. This is not important. This is the satellite, this is the right angle D, and this is the radar B. This is 25 degrees. This is the height. Now, the thing is, we know that the total length here is 350. So if part of that is X, if this is X, then the other part must be 350 minus X, right? Because they need to add up to 350. So this is 350 minus X. Okay, now let's set it up. The first triangle on the left, the trig function that relates the height, the X, and 40 is tangent. So tangent 40 degrees equals to the height over X. Okay, on the right-hand triangle here, we have tangent 25 degrees equals to the height over 350 minus X. Multiply both sides, solve for H, the height. So I get H equals to X tangent 40 degrees. And this one here, the height is 350 minus X tangent 25 degrees. Now, both of them equal to the height. So we can put them together, equate them together. X tangent 40 degrees, which is the height, must be equal to 350 minus X times tangent 25 degrees, which is also the height. We will solve for X here. Okay. Even though our final answer is not X, our final answer should be H, right? But once we get the X, we can use this to find the H. Right? Okay, we do that later. Okay, find the X first. Find the X first. So this is X tangent 40 degrees equals to 350 tangent 35 degrees minus X tangent 25 degrees. Now I add X tangent 25 degrees both sides. My purpose is so that I can factor that tangent 25 degrees. It's supposed to be 25. I know when you see this number, you are so tempted to compute that, right? We can just leave it there for now. Okay, we can compute that later using our calculator, but for now, just leave it like that. Focus on the X, factor the X. So we have tangent 40 degrees plus tangent 25 degrees equals to 350 tangent 25 degrees. So our X is equal to 350 tangent 25 degrees over tangent 40 degrees plus tangent 25 degrees. That's our X. Now you can use your calculator here if you want. Okay, you use your calculator. Compute the numerator first. Tangent 350 times tangent 25. That gives us 163.20768 over the denominator, tangent 40 degrees plus tangent 25 degrees. That is 1.3054. Let me put more, 073. So our x is 163.20768 divided by at 1.3 something. I get 125.02434 miles. But that's not our final answer. We need the h. We need the h. And we know h is equal to x times tangent 40 degrees. We already know the x, which is 125.20234 times tangent 40 degrees. That is equal to 104.90787 miles. Okay. That's for this page here. Let's go on. Number 11. Let triangle ABC have a right angle at C. Sketch that right away. Triangle ABC, right angle at C. Let's call this A. Let's call this B. Let angle A be 34 degrees. Side B is 9. Solve the triangle. When we say solve the triangle, it means we need to find the angle of three angles, the angle measure, right? And the length of three sides. That's what it means. Okay, we know angle A is 34 degrees and angle C is 90 degrees, right? Okay, we know side B is 9. Now look at that picture. Okay, what can we do first? I think we can find angle B, huh? So angle B, we know A plus B plus C is 180, right? But C is 90, so A plus B is 90 degrees, right? So B is equal to 90 degrees minus A, which is 90 degrees minus 34 degrees. That's 56 degrees. Okay, so that's 56 degrees. That's the first thing we get. Okay, now then, suppose I want to find side A. Suppose I want to find side A. This is side A here. Now, what relates side A and 9 and 34 degrees? What relates side A, the 9 and 34 degrees? That's tangent. Tangent 34 degrees equals to A over 9, right? Okay, so 9 times tangent 34 degrees equals to A, or actually, yeah, and therefore I use calculator 9 tangent 34 degrees give me A equals to 6.07058. Remember, 5 decimal places. Okay, you round it to 5 decimal places. So if the number is more than 5 decimal places, you round it to 5. How about side C, which is the hypotenuse? Side C, what relates side C, which is the hypotenuse, with 9 and 34 degrees? Oh, that's the cosine. Cosine 34 degrees equals to 9 over C. C times cosine 34 degrees equals to 9. So C equals to 9 divided by cosine 34 degrees. I get C is equal to 10.85596. Okay, so this is 10.85596. So we solved the triangle already. Okay, let's go on. Number 12. We have angle A, 35 degrees. Mark it on the graph. DC is 75 degrees, so this is 75 degrees. AB is 15, so the length here is 15. And then the question is find BC. This is BC here. Okay, let's call that X. Okay, and then find AC. Let's call that Y. Find CD. Let's call that Z. And AD. Let's call that W. Okay, now then take a look on that X. Actually, you may be able to do any one of these in different order. Okay, but I believe when I wrote that find BC, AC, CD, and AD, I wanted you to do it in that order. Okay, now let's start. Instead of using X, Y, Z, W, I will just call that as is. I will start from side BC. Let's do it here. Hopefully we have enough space. Now take a look on this right triangle here. This right triangle here. What relates 15 BC and of course angle A? That's the sine, right? Sine 35 degrees equals to BC over 15. Is it right? Okay, so BC equals to sine 35 degrees times 15. I'm sorry. So 15 sine 35 is 8.60365. That's our BC. So we are done with one of them. Okay. How about AC? Actually, we can use the same right triangle, right? Okay. AC, side AC. That's actually cosine of 35 degrees. Cosine of 35 degrees equals to AC over 15. So AC equals to 15 times cosine 35 degrees. AC is 15 cosine 35 degrees. That is 12.28728. That's our side AC. Now, how about CD? Now, CD is here. It is in this right triangle here. Now, the thing is, in this right triangle, we don't have the hypotenuse. We have the BC, though. We have the BC, right? Notice that BC is next door, right? So CD, what relates then? What relates CD and BC and 75 degrees? That's tangent, right? That's tangent. So tangent 75 degrees equals to BC over CD. CD tangent 75 degrees equals to BC. Let me just replace that right away. 8.60365. So CD equals to 8.60365 divided by tangent 75 degrees. That gives me 2.3 something. 2.30534. Okay. Now, last part. Notice that we know the CD. We also know AC, right? Okay. And use that to find this purple part, AD. Notice that the blue one, the yellow plus purple give you blue, right? Yellow plus purple give you blue. So we can say when we try to solve for CD, give me a second. When we try to solve for CD, you can see that, I'm sorry, not CD, my bad, AD, yes, AD. When we try to solve for AD, notice that that's actually AC, AD equals to AC minus CD. AC is 12.28728. CD is 2.30534. So AD is equal to 9.98194. Okay. Let's go on to the next page. I think it's the next page. Number 13. Oh, similar one. Oh, similar one. Here, angle A is 40 degrees. BDC is 70 degrees. Okay. Now, suppose AD is 25. Oops, AD is here. This is 25. Find CD and then BC. Find CD and then BC. Let's call this X. Let's call this Y. If I redraw the triangles, this is the smaller one. This is 70 degrees. This is X. This is Y. Now then the bigger one. The height are the same. Right angle. The height is same, pi, but the base is X plus 25, not X only. Now this is 40 degrees. Okay, then in the first triangle, we have tangent 70 degrees equals to Y over X. So X tangent 70 degrees equals to Y. In the second triangle, however, tangent 40 degrees equals to Y over X plus 25. So Y is equal to X plus 25 times tangent 40 degrees. Now both of them equals to Y, so I can equate them to each other, right? Oops, I don't have that much space. Let me move this. Let's leave it there. Okay, that's smaller. Okay, now I will equate them. Let me continue here. So x tangent 70 degrees equals to x plus 25 tangent 40 degrees. If you remember, we actually did a similar questions here, like the satellite problem, right? The difference is the satellite problem, the triangle, the satellite is in between, above the between, right? Now here, if you call this B the satellite, then they are not, the satellite is not in between A and D. Okay, but the way we work that out, still we still try to find the right angle in which they share something. Okay, so anyway, I distribute the tangent 40 on the right hand side, x tangent 40 degrees plus 25 tangent 40 degrees. So x tangent 70 degrees minus x tangent 40 degrees equals to 25 tangent 40 degrees. X times tangent 70 degrees, I factor the x out, equals to 25 tangent 40 degrees. So our x is equal to 25 tangent 40 degrees over tangent 70 degrees minus tangent 40 degrees. So let's see, what would that be? 25 tangent 40 degrees is 20.97749 over tangent 70 close parentheses minus tangent 40 times, that is 1.9083778, which will give us 20.97749. By that number, I get 10.99232. That's the x, which is our CD. Okay, now then what is the y? Now we know that x tangent 70 degrees give us the y. We know the x already, plug in number 10.99232 tangent 70 degrees equals to y. So y will be 30.201 something. Round to 5 decimal places, just make it 1. Okay. Let's go on. Number 14. I think this is the last question. Yeah. Number 14. In triangle ABC, AB is 40. So this is 40. AC is 100. Angle A is 20 degrees. Find angle C and find the length of BC. Oh, shoot. Yeah, to find angle C, we need to know two of these sides here. Okay, we need to know two of these sides here. Now, now of course, because we know the angle, let's take a look on this triangle here, this right triangle here. We know this the hypotenuse, okay, and we know the angle. So we will be able to find AD, right? And we will be able to find BD. Okay. Now notice that BD being shared by the blue triangle. Okay. And at the same time, once we know AD, once we know this AD here, then we will be able to subtract from 100 to get this length, right? 100 minus AD give us the green one. So our plan is this. This is our plan. This is our plan. Using this yellow triangle, we'll find this AD and BD first. Okay, let's do that first. Okay, in that yellow triangle. So to find AD, cosine 20 degrees equals to AD over 40. So AD equals to 40 times cosine 20 degrees. And when I compute this, I get 37.58770. That's my AD. Okay. Now from this AD, we can find CD then. CD is 100 minus AD, right? Because AD plus DC, or AD plus CD equals to 100. So CD equals to 100 minus 37.58770, which is 62.41230. That's the CD. Okay, so we already have this one. Okay, once we get BD, then we can use inverse tangent later on. Right, so let's find that BD. To find BD, that is sine, sine 20 degrees equals to BD times over 40. Sorry. So BD is 40 times sine 20 degrees. 40 times sine 20 degrees. That is 13.680805. Let's call that one. Now then, angle C will be tangent inverse of that. Tangent of C is BD over CD, right? Plug in numbers. 13.86, 0.680881 over 62.41230. Oh, what's that? That's 0.2 something. So C equals to the tangent inverse of that number. Actually, you don't need to get that decimal. You can just like use 13, tangent inverse 13.68081, blah, 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 you know, okay? This is tangent inverse of 0.21920. I get the C to be 12.36372 degrees. This question is considered difficult because you just need to answer one or two questions, right? Okay, in this case, to find the C only, right? To find the C only, you have multi-steps. So you need to be mature enough in, okay, what I need to do first, what do I need to do next, and put things together like that. Okay, is it difficult? If your mathematical foundation is weak, of course, that's maybe a difficult one. But this question is a standard question in trigonometry. All the questions I ask you in this test, especially the one with calculator, all those questions are standard in trigonometry. Okay. In fact, for chapter 1 and 2, if your teacher asks you anything less than these questions, then the instructor's actually not preparing you well enough. Okay, now I need to find BC though. I need to find BC. So this one is 12 something, right? This is 12.36372 degrees. Now, then what is BC? Let's see. Let me go on. So let me use sine. Sine C equals to BD over BC. Take a look on the triangle, on the right triangle. This one here. Okay, we have BD. We have the angle. We can use that to find BC. Okay. So sine 12 point. Actually, we can just use Pythagorean theorem to find that BD though. Yeah, you can just use Pythagorean theorem to find BD because we already have side BD and also side CD, right? We already have this side here and this side, so you can use Pythagorean theorem to get this one. Okay, you can do that. You can do that. I provide you another alternative here. I use sine. Okay, so sine of, you can compare, try to use Pythagorean theorem and then see if the answer match. If the answer don't match, but you did everything right, then it will be very, very close numbers, right? In other words, the difference is due to rounding error. Okay, now the BD is 13.68081 over BC, the one that we are looking for, right? So BC sine 12.36372 degrees equals to 13.68081. So BC therefore is 13.68081 over sine 12.36372 degrees. Now calculator time. And after that, we are done. 13.68081 divided by sine of 12.36372, I get 63.8944. Okay, now that's the review for our Summer 15 Math 241 Test 1 with and without calculator part. Okay, now again, when I say no calculator or with calculator, it simply means you don't use calculator if it is non-calculator. Okay, once you use calculator, then you will not get a nice answer. I'm sorry, this is supposed to be 414. Okay, so long.